Hello everyone, welcome back to another video. In this video, we're going to take a look at the November 2024 statistics question. So this was question 1 in the paper, and the question reads, at the beginning of a season, the coach of a junior boys rugby team recorded the weight in kilograms of the 15 players in his team and the number of push-ups that each player was able to do in 1 minute. The data is represented in the table and scatter plot below. The least squares regression line for the data is drawn. Now, we've been given the table, and also they've given us the scatter plot, and we can see the least squares regression line right here. Now, the question says 1.1, determine the equation of the least squares regression line for the data. Now, what I've done is I've put little screenshots of the steps that you need to follow and the things that you need to enter on your calculator in order to get this. Remember, you don't need to show calculation here. So if you are using a Casio calculator, then you need to go onto, or you need to ensure firstly that you are in statistics mode or stat mode. So the way that you do that is you press mode on your calculator. So on the top right, mode. And after clicking mode, you will then find, so mode, and then number 3 is stat. Then after clicking stat, you will be left with this screen. Now we want the equation of the least square regression line. So the least square regression line is y is equal to a plus bx. And so we then are going to click number 2. When you click number 2, you're going to have a table. And in that table, you need to enter in all of the data that you have. You can see here that they've given us the x values and they've given us the y values. Okay. Once you've entered in all of that data, you then press AC on the calculator. So you enter in all the data, you press AC. Then you press Shift and then number 1. Shift and then 1. And you'll have this screen. And then what you want to do next is you want the regression. So you press 5 and you have, so 5 here, and then you'll have the screen. So what we want is the A value, and then we want the B value. So the A value, so 1.1, if you press A, your calculator will give you that it is 39.46. So y is equal to 39.46, and then the B value is minus 0.59x. And that's the equation of the least squares regression line. Now moving on, question 1.2. Write down the correlation coefficient. Now the correlation coefficient is the R value. So what they want is the R value. So you repeat the steps. You don't need to enter the data in every time. You're just going to continue from here. And so we want the R value. The R value is equal to minus 0.8. Then question 1.3. The coach uses the least squares regression line to set the target for the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that a team member of the team who weighs 29 kilograms should do to meet the target. So here all we have to do is, for 2 marks, we just got to substitute. We are substituting a weight of 29 kilograms. Remember, weight is on my x-axis. So y is equal to 39.46 minus 0.59. And the x value, the weight, is 29. And so that means you get an answer of 22.35. So 22.35 push-ups. So the minimum would be 22, right? The minimum number of push-ups that the person will need to do is 22, because how do you do 0.35 of a push-up? I'm not sure. Question 1.4. Write down the mean number of push-ups for the data given. Now, if you want the mean is average. When you get to this point here, you're going to go AC, you're going to press Shift 1. Then, instead of getting this screen, you want to go to data. So Shift 1, you want to go to, not data, you go to VAR, variance. So you're going to go here. Now, you're going to have quite a few options there. For example, you're going to have N, you'll have X bar and Y bar. What you're looking for, they want to know the mean number of push-ups. Since push-ups, so push-ups are on my Y-axis, and we want the average, we are going to click the option that says Y bar. This means average of Y. Okay, so Y bar is option number 5. So option 5. And so the answer here, I'm going to write it in orange. The answer is 18. So Y bar is equal to 18.33. Next, question 1.5. The players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning. How does the increase in number of push-ups influence the standard deviation? It does not influence the standard deviation. What can I say? No influence. Okay? It has no influence on the standard deviation. Let's quickly take a look at Y. Suppose I have 3 data points, 10, 15, and 20, the average being 15. Now the deviation from the mean or the average is going to be constant. In this case, 5 on each side. Now if we add a constant of 5 to each value, I'm going to have new data points with the new average being 20. However, the spread remains the same. The spread is still going to be 5. So the standard deviation measures the spread. Adding constants shifts the values and does not change the standard deviation. And now the last question, question 1.6. Let's do that here. At the beginning of the season, the coach used the least square regression line as the minimum target for a player to aim for. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. So if my least square regression line is my minimum, so what I'm looking for then is I'm looking for the person that's done the number of push-ups that is the furthest away from that least square regression line. So if I look at this data, you can see here that it's going to be this person here. Whoever that was, they've done the least number of push-ups, or they've done the number of push-ups that is the furthest away from that regression line. So all I need to do is I need to figure out how many more push-ups does this person need to do to get to that regression line. So how many is that going to be? So all I need to do is I need to see, okay, so this person is 40, so 40 kilograms, and that is 6 push-ups. So we substitute this value in, we substitute the 40 in to the least square regression line. So Y is equal to 39.46 minus 0.59 times 40. And that gives us an answer of approximately 16. So that's for a 40 kilogram person, that's how many they should have done, but they've done 6. So the maximum number of push-ups that they're going to have to do more is going to equal 16 minus 6, which is 10 push-ups. Again, thanks so much for watching. Hope you found this useful. Don't forget to like, share, and subscribe, and I'll see you in the next one.